Okay, we might get started. Welcome everyone to our second AUSA Safe Work Month webinar. This will be on our Clean Air, Clear Lungs presentation. My name's Charles Nelson. I'm the Chemical Safety Officer at UniSA based in Adelaide. And I am the chair of the South Australian NT branch of AUSA. I'd like to respectfully acknowledge the Kaurna, the First Nations peoples and their elders past and present, who are the First Nations traditional owners of the land in Adelaide, where I'm based. We're honoured to recognise our connection to their lands and their history and culture, and we strive to ensure that we operate in a manner which respects our elders and ancestors. We also acknowledge other First Nations of lands across Australia and their elders, ancestors, cultures and heritage. This session, you will have seen when you logged in, is being recorded, so we will be able to load this session up, the recording of the session, to the website for AUSA members to access going forward. The presenter today, Sam, has also provided a copy of the presentation, so we'll also have that available to you. If you can please keep your microphones muted during the presentation and use the chat for any questions you might have. Myself and Teresa will monitor those in the background and be able to provide those to Sam at the end of the session. So we will have time for Q&A at the end. So October is, of course, National Safe Work Month. Being healthy and safe means being free from physical and psychological harm. And the theme for National Safe Work Month this year is Think Safe, Work Safe, Be Safe. So AUSA is excited to bring a series of webinars on these themes throughout the month, and I encourage you to check out and register for the other events that are free to all of our members. You can also follow us on LinkedIn and be kept up to speed with news and events through that. This webinar focuses on the WorkSafe theme, and this event will provide you with knowledge about the Safe Work Australia Clean Air, Clear Lungs campaign to raise awareness of occupational lung diseases and inform Australian employers on how to manage the risks in the workplace. So I'd like to proudly thank our presenter, Sam Hamilton, for joining us today. Sam is the Director of the Occupational Diseases and Hygiene Policy Group at Safe Work Australia. This team's work promotes and supports safe and healthy Australian workplaces by developing national policy and guidance on occupational hygiene, hazardous chemicals and diseases such as COVID-19, silicosis and other occupational respiratory diseases. So I'd like to welcome Sam and thank him for joining us today and pass it over to Sam now.
Welcome everyone. It's great to be able to be speaking with you today, and I'd really like to thank Charles and also Teresa for the opportunity to talk about our Clean Air, Clean Lungs campaign as part of Safe Work Month. I'll also talk about occupational lung diseases in Australia and some of the current policy issues that the agency is working on at the moment, including on Silica and also COVID-19. That'll be towards the end of the presentation. Bear with me while I share our slides. Fantastic. Okay, so in terms of a bit of a roadmap for the talk today, it's always good to give everyone an overview. I'll talk a little bit about Safe Work Australia. I'll talk about what occupational lung diseases are and give an overview of occupational lung diseases in Australia. I'll talk about our Clean Air, Clear Lungs campaign and also really encourage you to look at some of the materials that have been developed on our website. I'll talk about our workplace exposure standards review for hazardous chemicals, which is a major piece of work that the agency is undertaking this calendar year. Talk about our program of work on silicosis and silica-associated diseases. And lastly, talk about our COVID-19 WHS guidance. And I expect that's going to be quite a bit of interest to you, and we'll leave some time at the end for any questions that you might have. I'll promise to do my best. So just briefly about Safe Work Australia, we're a tripartite body that works in partnership with governments, employers and employees to drive national work health and safety and workers' compensation policy development. We're governed by a group of members, which has an independent chair and representatives from all the jurisdictions, including the Commonwealth, as well as two representatives each from our social partners, representing employers and workers. It was set up in 2008 to oversee the harmonisation of WHS laws within Australia, and our work promotes continuous improvements in safety outcomes, and we really strive to ensure that they're practicable for small business and workers and other groups of employers as well. We'd like to see ourselves as a key source of information, as well as data and research on WHS policy issues and also on workers' compensation. So onto occupational lung diseases. Well, I'm sure many of you are very well aware of many of the common occupational lung diseases in Australia as WHS professionals, but we've grouped them together in this infographic for the purposes of our campaign into diseases like work-related asthma, COPD, the pneumoconioses or fibrotic lung diseases, which includes coal workers' pneumoconiosis and various forms of silicosis. But there are also other forms of occupational lung diseases that are present in Australia: hypersensitive pneumonitis, toxic pneumonitis, alveolar proteinosis. But what's also not on this slide are some of the cancers. We're well aware of mesothelioma, for example, that's associated with asbestos inhalation, but also infectious diseases like COVID-19 and Q fever, which is also a feature of this campaign. Last year, we published a review of occupational lung diseases in Australia from 2006 to 2019, and I'd really encourage you to have a look at this review if you're interested in more details. It really synthesised the available data from the peer-reviewed literature, grey literature, and also other data sets to try and make some conclusions about the incidence, prevalence and trends in occupational lung diseases in Australia. Its main conclusions are on the slide: that the incidence of coal workers' pneumoconiosis and silicosis is increasing. Claims for asbestos-related diseases continue to decline, but unfortunately deaths are increasing. Claims for work-related asthma appear to be declining, but there's evidence internationally that suggests that these may be underreported. But in general, there are really few available data within Australia on other occupational lung diseases. And that's one of the reasons why we've launched the Clean Air, Clear Lungs campaign. It's a national campaign to raise awareness of occupational lung diseases and to educate persons conducting a business or undertaking, or PCBUs, on what they can do to manage these risks at work. So the sorts of hazards we're interested in are dusts, gases, fumes, vapours, mists, and also microorganisms as well. A key part of the campaign is to try and make people aware that these hazards aren't always visible in the workplace, but they're certainly something that PCBUs need to consider. And the campaign focuses on four industries: the manufacturing industries, construction sector, agriculture, and also the engineered stone sector as well. So if there's a hyperlink at the end of this, and as Charles said, I'm really happy to share these slides. So I'd really encourage you to go through the materials, explore them and use them for your own purposes. The campaign takes an identify, manage and monitor approach. So to encouraging PCBUs to identify hazards and assess risks in their workplace, to eliminate and manage those risks, and to monitor and review those. And I'll just go through some of the information that's in the campaign on the next slides. So with respect to identifying hazards and assessing risks, it talks about the duty of PCBUs to identify if there are hazardous substances present in their workplaces, and encourages PCBUs to consider these hazards, talk and consult with their workers, read labels and safety data sheets on the chemicals that are present in the workplace, talk with their WHS regulators, and also, where necessary, engage professionals like occupational hygienists. In terms of risk assessments, we're really encouraging PCBUs to undertake these, considering the likelihood and consequences of the identified risks, particularly considering how, where and how long workers could be exposed, the control measures that are already present in the workplace, and ways that they can measure how well these control measures work. I'm sure you're very well aware of the hierarchy of controls in your workplaces and in your work, but we're really encouraging PCBUs to eliminate and manage these risks according to the hierarchy of controls as is required under legislation. So of course, PCBUs must eliminate the risks of breathing in hazardous substances, and that must be considered first. But if that isn't reasonably practicable, they must minimise these risks as insofar as is reasonably practicable. So we offer some examples throughout the materials around ways that people could start thinking about substituting hazards with a safer alternative. So for instance, in the case of engineered stone, using products that don't contain silica. If that's not possible, then PCBUs should isolate the hazard from people. And as an example of that with engineered stone would be using automation with CNC machines to cut engineered stone. It also talks about engineering controls and the role of administrative controls and also the use of personal protective equipment. In terms of the monitoring and review, we're really trying to focus the message that risk management is an ongoing process and it's important to regularly review and monitor controls. And it talks about what PCBUs must do in terms of reviewing control measures. So of course, when the control measure is not effective in controlling the risk, before there's a change at the workplace that's likely to give rise to a new or different health and safety risk, if a new health or safety risk is identified, if results of consultation indicate that they need to review the risk, or if an HSR requests a review. There's a whole range of specific resources that are available as part of this campaign. And as I said, I'd really encourage you to go through these. We have information sheets directed at each of the industries that we're targeting. We also have case studies, posters, infographics, animation, and social media as tiles as well. So once again, I'd really encourage you to visit the site at safeworkaustralia.gov.au/clearlungs and explore those material and propagate them and make sure they're used. Another piece of work I'd like to talk to you about today is the Workplace Exposure Standards review that the agency is undertaking. Just briefly, I'm sure many of you are well aware that a workplace exposure standard sets limits of the airborne concentrations of a chemical that's not expected to cause adverse health effects in an exposed worker. They're generally expressed as a time-weighted average or a short-term exposure limit or a peak limitation. And under legislation, workplaces must ensure workers are not exposed to hazardous airborne chemicals above these limits set out in these workplace exposure standards. In 2018, we started a review of these standards. They've been in place since 2003. And certainly it was timely to undertake a wholesale review of these. The WES review process has developed an agreed methodology that's been agreed by work health and safety ministers. As part of this process, we've engaged independent experts to develop peer review health-based recommendations for the workplace exposure standards for each chemical. And these are currently being reviewed by the Safe Work Australia member body and will be progressed to work health and safety ministers for agreement. So I must say it's a huge piece of work. The team's reviewing the workplace exposure standards for over 700 hazardous chemicals. And provided that they're agreed and enacted by states and territories, we expect that they'll be in force by 2025. I'd also like to talk to you today about the body of work that the agency's undertaken to address the risks of silicosis in workplaces. So silicosis is a progressive lung disease that's caused by the inhalation of respirable crystalline silica, so very small particles of silica dust, less than 10 microns in diameter. So that's about 1/5 to 1/7 of the diameter of a human hair. Chronic inhalation of silica can cause inflammation and scarring in the lungs, and that's the etiology of silicosis. One of the difficulties with managing this risk is the long latency period between the first exposure and the disease. Now, while we can see acute and accelerated forms of silicosis that may occur within a few years of the first exposure, some exposures may lead to people developing silicosis within 10 years or more. Unfortunately, there's no known cure for the disease apart from a lung transplant. And as you very well know, it's debilitating and can be fatal. Silica is not only associated with silicosis, it can also cause other occupational respiratory diseases like progressive massive fibrosis, COPD, chronic bronchitis, various forms of lung cancer, chronic kidney disease, and it can also precipitate autoimmune disorders like lupus and scleroderma, which affects the connective tissue of the body. So silicosis is really a re-emerging disease in Australia. The first recent case associated with engineered stone was reported in the literature in 2016 in this paper that you can see here, and that health screening programs have been enacted in many states and territories, and these have identified hundreds of cases of silicosis in engineered stone workers. So between 2010 and 2011, that financial year, and 2019 and 20, there've been about 950 workers' compensation claims accepted, and I think about 60% or so of the claims within the last 5 years have been within the last financial year. So certainly the burden of disease does seem to be increasing. It's also important to note that the disease isn't limited to stonemasons, despite the focus on stonemasons and engineered stone, particularly in the media, and it affects quarry and mining workers, bricklayers, and a whole range of other labourers as well. So in terms of the work that the agency and its members have undertaken to minimise the risk of silicosis in Australia, the first piece of work that we've completed is reducing the workplace exposure standard for respirable crystalline silica. So in 2019, the ministers agreed to reduce the time-weighted average from 0.1 milligram per metre cubed to 0.05 milligrams per metre cubed 8-hour time-weighted average. So this is one of the lowest workplace exposure standards in the world, and this has now been implemented in all jurisdictions with the exception of Tasmania. We're also just about to release a model code of practice for people working with engineered stone. Model codes of practice in themselves provide practical guidance on how to achieve the standards of work health and safety underneath the model work health and safety laws, but they have to be enacted within the jurisdictions for them to be approved as a code of practice and used in court proceedings. So this code of practice sets out the requirements for duty holders under the Model WHS Act and its regulations, and provides information in general about engineered stone and respirable crystalline silica and the health effects of inhalation of respirable crystalline silica. It clarifies who has health and safety duties under the WHS laws, how they should and must manage and control the risks of exposure to respirable crystalline silica in their workforce. Talks about maintaining and reviewing control measures. Also talks about the WES for respirable crystalline silica, duties for health monitoring, air monitoring, and also, and importantly, cleanup and disposal of silica dust in the workplace. Another piece of work that we're progressing at the moment is to include some avoidance of doubt regulations to prohibit the uncontrolled processing of engineered stone, because the uncontrolled processing of engineered stone is more likely than not a breach of the Model WHS laws. So at the moment, we're preparing a regulatory change to expressly prohibit uncontrolled cutting, grinding, trimming, sanding, polishing, or drilling of engineered stone with power tools and plant. We're also undertaking a regulatory impact analysis on other options to minimise the risks of respirable crystalline silica exposure within Australia. So in case you don't know, a regulatory impact analysis is the process that's required to implement regulatory change And it's a formal process of describing the problem, identifying regulatory and non-regulatory options to address the problem, assess the impact of those options, of the proposed regulation under those options, and also has a formal consultation process with stakeholders. So one of the things that this will consider will be to consider the licensing of persons conducting a business or undertaking who work with engineered stone, as recommended by the National Dust Diseases Task Force. And they handed down their report in June 2021 of this year. It's worth a read if you're interested in dust diseases in Australia.
It looks like we may have lost Sam there for a second. While we're waiting for Sam's connection to come back up, if people do have any questions, they can use the chat function to put them in, and we'll raise them with Sam afterwards at the end of his presentation. While we're waiting for Sam to come back online, there will be a couple of questions that I'm interested to know about from my perspective. The silicosis is an interesting one that seems to have been focused on those industries around engineered stone products, but it's definitely come up at UniSA in the arts sector, in our arts teaching, where we do glazing and pottery, and that they use silica as part of that. So we've got some hygienist studies in for that usage. So I'd be interested to see whether there might be any further information that Sam can provide us on those kind of industries that aren't covered by the main focus of the reports so far. Sam, are you back with us? Okay, can everybody hear me all right?
Yes.
Yes.
Excellent. Okay. Wasn't quite expecting this to happen, so hopefully Sam will be able to join us again shortly. Has anybody else looked at silica type issues in any of your areas within the university? Is there any areas that have been raised as potential issues for silicosis or exposure to silica out there?
Yes, I have.
And what parts was that for you, Mikhail?
Hi everyone, I'm Mikhail. I'm a health and safety advisor with the University of New South Wales, and in the School of Mining Engineering, or now the School of Mineral and Energy Resources, we had a huge lab. It works for both research and teaching, and in it we had a big crushing and sieving machines for different types of rocks. For demonstration and demonstration only, the technical officers and the academics used to just bring buckets of sands and crush it in the crushers, and then put it in the sieving the machines, just to show the students how it's happened. However, sand is very high in silica, especially when it's crushed. We did hire a consultant because we had a dust issue in general in these labs, and the consultant confirmed that we have 400 times the maximum exposure for silica because of the use of the substance. Also, we didn't have any mechanical extraction enforced in this place, so we had to work on different lines. The first is to eliminate the source of the silica dust, and the second is, and the other ones is to improve the lab quality in general. So because we have a general dust problem and a silica dust problem. So with that one, we try to use amorphous silica. Amorphous silica dust, amorphous silica particles is doesn't release respirable crystalline silica particles. And it's well known to be used in such types of research and work, or use different types of rocks that wouldn't emerge any hazardous dust, even though it's still a dust, but it's not hazardous. So we can the method we use is we do XRD or XRF for the rocks to analyze the components within those rocks and know what is harmful and what's not harmful, and if it's harmful, we avoid using those types of rocks. And this way, we eliminated the use of respirable crystalline silica or any other dust that might be hazards to be used in those spaces. In the space itself, we improved the mechanical extraction there. We implemented a whole new system. According to recommendation of the extraction, we needed a specific airspeed or airflow in there. So we installed the equipment that has the capacity to work in 5 different positions at the same time, with 1.5 to 2 times the recommended levels of air extraction, which is fantastic. The initial quotations or pricing we were expecting sits around $300,000 to renovate this type of lab with the mechanical extraction, everything. However, we managed to do all of this for around 100K. The other thing that we agreed on to have a visual monitoring for dust levels, and whenever see any dust build up in there, we can do some tendon eliminations testing, and if we found to have a source of dust that produces more dust than usual, we can then do a qualitative and quantitative analysis on this type of activity. But generally speaking, now it's way better than what it was before. And it's always a start with the safe work roadmap. And when they brought up the silica issue and the silicosis in the workplaces, the university took it on board, and we had to look into it very deeply. So that was my experience with some of my labs in engineering.
Thanks for sharing, Mikhail. It was excellent. Yeah, very detailed analysis and review. And yeah, we have similar processes at UniSA where they're working with minerals and ores and samples coming from mining industries, and doing further analysis on those. So one thing that we've done, we had extraction systems in place in some of those areas, but there was still some potential risk in a number of areas. So we got one lab in particular where we got them some powered air purifying respirators that they now wear as well. So a full face respirator mask for working in those activities as an additional control, especially when they were cleaning the material, so they or the equipment that they use. So it's one of the additional items in there. Unfortunately, I haven't been able to contact Sam. I tried giving him a call and wasn't able to get him. And we've also been trying to email him as well to get him back online. So I'm not sure what's happening there, which is a bit unfortunate.
If I have a question to ask, because that was raised when this issue came across the campus. Why don't we have a centralized location where we do all the dust-related activities, and it would be like equipped with all the benchmark technologies and equipment in order to mitigate these types of risks? However, that talk was killed by COVID hit on campus. So I wanted to know if any of the universities would have like a hub for similar activities at all, or it's again scattered across the different units and departments.
Go on, Maria.
Oh, yes. No, TQ is spread across the different departments. There hasn't been any talk of any hub in the mineral activities to really increase the level of protection to the researchers doing that type of crushing and milling and all that. But yeah, it would be lovely, it would be wonderful, but yeah.
I think that's a really interesting idea, Mikhail. I think there's a bit of territory and a bit of real estate and competition that might come into that too. But we've had a few discussions around treating these products maybe as a dangerous good. Oh, Sam's joining us back. Maybe treating them as a dangerous good as well, and how you sort of manage them through the life cycle too. I'd be interested to hear if you guys did any monitoring, and if you did, what sort of levels you got as well compared to the occupational exposure standard that Sam was mentioning earlier.
Sam, you're back online.
Oh, my sincere apologies, everyone. I was running through all of the slides, doing a great job, and unfortunately no one was listening. So I sincerely apologise for my patchy Wi-Fi.
That's all right. If you want to.
Where did I get up to?
If you want to bring the slides back up, I think it was still in the silicosis area. That.
Okay. Well, again, sincere apologies for everyone. I'll just. How about I talk through the just quickly about silicosis and the work exposure standards, but I'll really focus from now on about COVID, because I think that's probably the most interesting piece of work. And again, sincere apologies for that. Okay. So some of the work that we're doing on silicosis is implementing a model code of practice for engineered stone, developing avoidance of doubt regulations to prohibit uncontrolled processing of engineered stone, and also undertaking a regulatory impact analysis on the options to minimise the risks of respirable crystalline silica exposure in workplaces beyond just stonemasons. So this will also consider regulatory and non-regulatory options in a range of industries, including quarrying and mining, etc. Now onto our COVID guidance. I should say that our COVID guidance is probably certainly our most visited page on the Safe Work Australia website. It's very popular. We get about 2.6. We've had about 2.6 million hits on the website since the start of the year. Just to give you a bit of a context of that guidance, it says that employers must follow any public health orders that are in place in their jurisdiction, of course, but under the model WHS laws, to minimise the risks of COVID-19 in the workplace, PCBUs must continue to assess the risks, consider the effectiveness of available control measures, consult with HSRs, consult, cooperate and coordinate with other duty holders, and determine what control measures are reasonably practicable to implement. We also conclude that in many cases, it is not possible for PCBUs to eliminate the risks of COVID-19 at the workplace, and that combinations of control measures are likely to be required to minimise this risk so far as is reasonably practicable. Some of the control measures that we're recommending PCBUs consider: ensuring workers don't come to work when they're unwell, practicing physical distancing, vaccination, ventilation, good hygiene, cleaning and maintenance, and also wearing of masks. We've just released this week some guidance on COVID-19 vaccination, and in the PDF document that Charles can send out, the hyperlink at the start of this, in the title of this, will give you, will lead you there. We conclude that vaccination is a safe and effective way of keeping the community safe, that the vaccines available in Australia are highly effective in protecting people from the serious health effects of COVID-19, but vaccinated people may still become infected and infect others, and other reasonably practicable control measures must continue to be implemented at the workplace. Whether it's reasonably practicable or not to implement a mandatory vaccination program will depend on the circumstances of the workplace and the workers at the time of the risk assessment. Some of the factors that should be considered include availability of vaccines and any public health recommendations for the workforce, the extent of community transmission, where the workplace or workplaces are located, the likelihood of worker exposure when they're doing their duties, and also the likelihood of a reduction in transmission, whether workers or the people they're in contact with are vulnerable to severe disease, whether there are other control measures, the other control measures that are in place, and also whether a requirement for mandatory vaccination could be unlawful. So whether does it discriminate, for example, against some classes of workers, but there are a whole range of other factors in that guidance that you can consider. We're also revising our guidance on improving indoor ventilation and doing so in consultation with the AHPPC. And that's because of the emerging evidence around Delta and the increased likelihood of aerosol transmission. So this guidance will include practical strategies to improve natural and mechanical ventilation based on internationally available materials. And if pending the release of this guidance, you need a steer towards some other materials that are good to cover these issues. The WHO roadmap, the US CDC ventilation in buildings site, and also the UK HSE executives website are also very useful. Our guidance will consider the use of air purifiers and CO2 monitors, but the most important point is that it won't be an engineering manual. It won't replace the need for consultation with ventilation engineers or occupational hygienists. We're also revising our guidance on masks and PPE following the emergence of the Delta strain, and we'll provide more detail about the types and uses of different sorts of masks, from cloth masks all the way through to surgical P2 and N95 respirators. One of the really active pieces of work we've got underway is to provide some advice for workplaces on the use of rapid antigen testing. As you're probably well aware, the TGA is preparing to approve the use of rapid antigen tests without medical supervision on the 1st of November 2021, so in only 2 weeks. And we're working with other government agencies to develop practical guidance particularly for employers on this issue. So very much watch this space. But we've got a range of other useful COVID-19 resources on our website covering general information, duties under WHS laws, workers' rights, risk assessments, physical distancing, hygiene, cleaning, mental health, emergency planning, and a whole lot more. So I'd really encourage you, if you haven't already, to explore those resources on our website. So lastly, just in terms of messages, please share our Clean Air, Clear Lungs materials. Silica and silicosis, silica-associated diseases are major priorities for Safe Work Australia. We're expecting to complete the workplace exposure standards review by the end of 2021, and our COVID-19 resources are a good source of information on minimising work health and safety risks. So on that note, thank you very much. Thank you for your patience with my IT difficulties, and over to you.
Excellent. Thank you for that, Sam. That was very informative and great to provide all of those additional resources where we can find out further information. I might start off the questions with a couple to do with the workplace exposure standards. So there's a couple of areas, especially in my work environment, where we've had queries come up in the past, and there's also potential for change going forward. So one of those is around formaldehyde exposure, which is very pertinent within our anatomy labs within the university. And now I think the plan was that the formaldehyde exposure was going to be significantly reduced in the draft standards from when I was looking last year. I'm not sure whether there's been any further movement in that. By the look of things, that'll go through to the end of this year before those kind of finalised, and then a number of years going forward from that. But do you have any, I know that there was a number of bodies, including the Australian Anatomy Society, that was providing responses to the the draft exposure standards, new exposure standards for formaldehyde. I don't know whether you can comment on that generally, or whether you have any further specific knowledge, but I'd be interested to see, because that could potentially impact quite a few universities in their anatomy labs and exposure to staff and students from formaldehyde fumes when working with cadavers.
Thanks, Charles. And look, my background a long time ago was as a veterinarian, so I've almost bathed in formaldehyde throughout my undergraduate teaching and also in practice. So I'm very well aware of the realities. I can't really comment on some of the committee in confidence discussions about formaldehyde. Suffice to say that we've received lots of submissions about the issue, not only from universities around the use in anatomy studies, but also uses of formaldehyde in manufacturing as well, particularly from timber products. So that's under active consideration at the moment. So I'm sorry I can't give you a more specific answer, but I hope that
that's fine.
Certainly been heard.
Yep. And the other one was around welding fumes. I haven't seen, I thought that they were still being considered in the workplace exposure standards, but I saw this week I got an email from a body, the welding organisation, that seemed to indicate that they were looking at removing any workplace exposure standards from welding fumes. I can't imagine that would be the case, but just wanted to understand whether that was still being considered.
Yeah, look, and that's a very hot topic, as you well know. Our members met yesterday and did have a discussion about that. Look, the proposal was to remove a general workplace exposure standard for welding fumes and look at the constituent chemicals of welding fumes instead. Now, of course, there was quite some concern, particularly from workers' representatives about that, particularly because of how feasible it is to use a gravimetric method to measure welding fumes rather than specific methods for individual chemicals. So that was considered yesterday by members, and I think it's public knowledge. Certainly the union movement, I think, put it on Twitter this morning that they've reconsidered that.
Okay. There you go, hot off the press. Okay, so I haven't seen any other questions come in. Teresa, have you seen any other questions that I may have missed?
Oh, nothing yet. I did just my little question that I had is: anybody monitored their workplaces with regard to doing personal exposure monitoring or airborne dust monitoring, and got any levels in a university setting?
At UniSA, I can comment that we've definitely done monitoring for formaldehyde within the anatomy labs a couple of years ago, and followed on with reviews and assessments around that, and changes to some of the work practices and also some of the infrastructure around that to try and improve exposure or reduce exposure to those fumes. And we've also done some monitoring for silica exposure within engineering facilities where they create concrete and range of different additives within that, and then test the strength of that. And also within our art sector in the glazing, glass blowing and pottery areas around exposure to silica that are used in those products as well.
And is that...
Sorry, I was going to say, likewise, University of Technology has done baseline exposure monitoring for crystalline silica as well by our engineering department.
I know there was some nervousness in the construction industry when, as Sam mentioned, when the occupational exposure limit was halved, about how that was going to be, how practical that was in some settings. So I guess, has there been any alarm bells in a tertiary education area where 0.05 is either difficult to monitor for, or we're getting close to those levels?
The only area, so in our engineering area, with all of the extraction systems and controls that we had in place there, the levels were much lower for silicosis exposure. General dust was coming up, was a higher exposure levels than silica for that. And in the arts sector, there was within the creating of the for the technical team, when they, because they basically deal with the silica in bulk and then provide it in smaller quantities for students to use. The levels there were not at workplace exposure standards, but getting up where we wanted to make sure that we had better extraction systems around those areas. The formaldehyde fumes, we did have some workers exposed to that levels where it was above the proposed lower standards. Not above the current standards, but above those proposed lower standards, which is why we then looked at further engineering controls to try and address those issues in ESA. Not sure whether anybody else at other universities has had similar experiences.
Yeah, so as I mentioned while Sam wasn't here, we did the monitoring. It wasn't only engineering, but we had in some other science facilities and civil engineering as well did their monitoring in there. We had specific locations monitoring general dust exposures, and we also had personal samples collected from each person doing different activities. However, after drawing the baseline and getting the levels under the proposed or the new level of exposure, so we're currently not doing any quantitative analysis, but we're just doing monitoring on the dust levels, as in qualitative analysis. We see if there is any dust, then we implement more different types of monitoring for it, but we don't have a continuous monitoring for the dust levels. The University of New South Wales, that's at the University of New South Wales.
Yeah, at TQ, Brian Logan started to do a lot of monitoring in certain areas that we were aware that we're doing crushing, milling, etc., to control, to monitor, to see what the levels were at, but I'm not 100% sure what was the level. And but certainly we have not progressing with doing continuous monitoring.
Peter Sophos here from Monash as well. We've done quite a bit of monitoring on formaldehyde in our anatomy setting as well. We did some significant changes to our facility to try and achieve a waterfall type effect, where we're getting the ventilation coming down and then being sucked out through grills under the tables. We've conducted both personal monitoring and background monitoring. We've done personal monitoring for 8 hours and also for 15-minute STL, so changing over the tubes at 15-minute intervals so we get direct information. Our levels have been fairly good, although we are just above, I think, the new proposed limit. So similar, I guess, to your comment there, Charles, in relation to what you saw with your area. But we have allowed contingencies in our system. So if we do need to put additional ducting to try and ramp up should the new standard come in, we have put some provisions for that, and we will continue to monitor that, I guess, once we're back to teaching, with students on a regular basis as well, just to make sure the levels are staying intact.
Excellent, thank you, Peter. We have a question that's come in around monitoring for dust and VOC from laser cutters and 3D printers. I know that we've had those issues raised, but we haven't done any specific monitoring at UniSA. Sam, I was just wondering, is that an area that SafeWork Australia has done any work in around looking at those items? 3D printers are going to become more and more common, whether they be industrial type and commercial type 3D printers or the little desktop ones. Be an interesting space.
Oh, I think so, Charles. And look, the short answer is no, but the longer answer is we probably need to think about it as an emerging, or at least even an emerged issue within workplaces in Australia. So I'll take that one on board. Thank you.
Thank you. Does anybody else know any other unis that have done some detailed analysis on exposure within those spaces?
It's Glenn here. Can you hear me?
Yep.
Yeah, at QUT in Brisbane. We did some monitoring, got some external hygienists in to monitor our laser cutters and 3D printers in our design studios, and pretty much identified that levels were quite low, except we did find that with the laser cutters, the dust that can be generated really needs to have a good ventilation system, both a push and a pull ventilation system. And we did find some higher levels of dust in some of the joins and under the doors, near the scrubbers, and we've fixed all those areas, but certainly interested in any ongoing research on levels and standards.
Excellent. Thank you for that, Glenn. So do we have any other questions for Sam? People out there that might want to voice their queries directly?
I suspect people are probably a little tired of talking about COVID already, but Sam, I think you raised some really interesting points around COVID there. Any silver bullets you'd give us to be as safety professionals? I guess the interesting thing about COVID is it's become bigger than one department or one area. Any silver bullets you'd give us as safety professionals to be conscious of and take back to our organisations?
Look, I don't have any silver bullets, I'm afraid. I wish I did. I wish it was a risk that we couldn't eliminate. And but I think COVID's here to stay, and things are going to change very quickly in the coming months as Australia opens up under its roadmap. The one take-home point I suppose I'd give you is no one single control measure is going to be reasonably practicable by itself. It's going to be combinations of controls. And my personal opinion is that as we see public health orders relaxing, and that's bound to happen over time, there's going to be more and more focus on the WHS risks underneath the model WHS laws. And so that's going to keep us very busy trying to provide practical guidance for people that's going to be useful in all the settings. And I've just been reflecting on the sorts of settings that all of you work in, which range from different faculties and different departments in experimental laboratories all the way through to probably even agricultural facilities at many of your universities as well. So it's difficult enough for you within a university context, but then extending that more broadly out into other contexts as well is going to be a massive challenge for all WHS professionals. So just to reiterate, no one control measure. Vaccination is not going to be a silver bullet, although it's going to be very, very useful. And we're going to really have to assess risks and continue to monitor the effectiveness of controls. And I haven't even spoken about workers' compensation either, which is even more complicated, I think.
Yes, that's a very complex problem, and dealing with that and all the, I suppose, legal issues associated with that. So we might leave that topic to another time.
I'm not the right person either.
Excellent. Well, thank you very much, Sam, for that presentation. Very interesting, raised lots of questions and queries, and I would like to thank the members that provided information on what they were doing at their university around exposure to occupational dust and potential for managing diseases or fumes as well within those spaces. Just like to remind everybody that we do have 2 more of these sessions. So there's one next week that's on safety and design. So that should be an interesting topic around looking at what we can do to try and manage our workplace environments. So you can sign up for that event if you haven't already done so. And of course, you can follow us on LinkedIn to see what else is going on in those places in terms of events or activities for AUSA. So thank you very much for joining us, and I hope to see you all at our next session next week.
Thank you, Charles.
Thanks for the opportunity, everyone.
Thanks, Charles.
I'm sorry about dropping out.
Thanks, Sam.